Okay. Once again, this go-to training is for ALEKS assistants. So what we'll do is, if there's a concept in ALEKS that you guys need help with, okay, you'll just provide me with that concept in the chat box, and then I'll cover that concept. Okay. So for instance, if you were having problems with fractions, and you've got a whole load of concepts with fractions that you're having problems with in ALEKS, then you can just type that into the chat box. Need to know more information about fractions, and then I'll cover that concept. Okay, so let's get started. Okay, so who would like to be first? What is the first concept? Okay, so you're having problems solving distance, time, and rate problems. Okay, not a problem, Jennifer. Okay, so what we'll do is we'll put up um, a distance. We'll put up one of those kind of problems. Let me put in new feed, new blank document. Okay, so we're going to put up this new document here. Okay, so what we're going to do is we're going to say, okay, here we go. If two cars are traveling, let me say, I'm just going to say if car A, let's put it that way. If car X is traveling at 55 miles per hour, and car Y is traveling at 50 miles per hour, how long will it take for both cars to be 315 miles apart? Apart. Okay, so this is a question. Okay, and this is typically the way the DTR problems work. They give you a word problem, describing a situation, and then you got to kind of figure it out. Okay, so what we're going to do is we'll look at the formula. The formula says distance equals TR. Okay, so that's the formula. Distance equals TR. Okay, now you can substitute TR in for distance at any point in time. Okay, so that's our formula. Now the way I'm going to solve it is I'm going to look at this where I'm going to say, okay, well, one car is going to cover a certain distance. So that's going to be distance 1. Another car is going to cover a certain distance. That's going to be distance 2. And then they're going to equal the total distance apart. Okay, so that's the way it works, total distance apart. Okay, so there we go. Okay, so that's the way I'm going to set it up. Okay, so I'm going to say, one car is going to cover a certain distance, and then the other car is going to cover a certain distance. Then when you add the two distances together, so I'm going to say, okay, I know when I add these together, it's going to equal 315 because that's the total distance. And now I'm just going to fill in the information that I know. Okay, well, I don't know what the first car's distance is, and I don't know what the second car's distance is. So what I'm going to do is I'm going to go, let me see if I can, let me highlight it. I'm going to go to this formula right here, this equation. And then I'm going to take out all the D's and put in TR's for them. Okay, so that's the way it's going to work. I'm going to take out all the D's, and I'm going to put in TR's. Now, the T stands for time. The R stands for rate. So really what we're saying is the distance equals the time, if I can get time spelled right, multiplied by the rate. Okay, so that's what I'm going to do, because and the reason why I'm going to take out the distance is because I know nothing about it. But I do know something about the TR. I know what the rate is, which is 55. and I know what the radius on the other one, which is 50. And knowing something is better than knowing nothing. So that's the way I'm going to work it. So I'm going to take out the D1 and put in TR1, and then TR2, okay, and then that's going to equal 315. Now, at this point, I don't know what the time is, but I do know what the rate is. I know that the rate is 55, so that's going to be 55t. And then I know the other one's rate is 50 miles per hour. That's going to be 50t equals 315. Okay. Okay, so I've got half of the information. That's the reason why I took out the distance, because I didn't know anything about the distance. Okay, and so when you don't know anything, that's not good. You got to know something. So, I took out the distance and traded it for the TR. And the reason why I can do that with the distance, because that's called the substitution property. Okay, now the substitution property is a math property, property that states if two things are equal, you can replace one with the other. Okay, so that's what the substitution property says. Okay, the substitution property is much like the distributive property, the associative property, the commutative property, the identity property, all those other properties we've learned. The substitution property is just like that. Okay, it's a rule that always works in math. If two things are equal to each other, you can replace one with the other one. Okay, like say for instance, if I say, well, I equals the principal times the rate times the time. Okay, so what that means is that we can replace I with PRT. Okay, so that's what that means. When two things are equal to each other, you can replace one with the other one. So if we say, and I'm just making this up, this has just been made up. An apple is equal to a banana. Okay, banana. All right, still spelled it wrong, but the auto corrected it. Okay, put a B in here. Okay, so what that means is that I can replace an apple with a banana because they're equal to each other. So that's what the substitution property means. Okay, that property is going to be important when you're solving these kind of problems, because you're going to find that you're going to have to be replacing stuff all the time. Now, that I want to do one more thing with that D with the D equals TR. That formula can be manipulated. Okay, you can change stuff around. Like you can divide both sides by R and come up with D over R equals T. Okay, so you can do stuff like that with it. If you divide R from the right side and R from the left side, you end up with D over R equals T. So you can manipulate that formula. And then another one, you can say, you can divide both sides by T, and come up with this right here. Okay, all of these equations are going to be equivalent to each other. Okay, so we can say, well, in order to find the time, you divide the distance by the rate. In order to find the rate, you divide the distance by the time. Okay, so we can manipulate things like that. Okay, now once we get to this point here, okay, I'm gonna make it blue. Once we get to this point right here, it's all math. We've now converted all of the English, all the language to math. At this point, it becomes a linear equation. Okay, we've got two expressions. We've got an expression on the left, expression on the right. We got 55t plus 50t. We can add those together and come out 105t. Okay, and then that's going to equal 315. Okay, and that's an expression, we added the 55 and the 50. And the reason why we can do that is because they're both t's. Okay, now the last step is going to be divide both sides by 105. Divided by 105. Put t divided by 105. And then we're going to divide this side right here by 105 too. Okay. And all we're doing at this point is undoing the operation. We're just getting rid of the multiplication of 105 by the division of 105. So we got t. And then t equals 3. Now what is t? T is the time. Okay. And so the question asked us, how long will it take? And I'm going to go back up to the beginning and make that red. So they asked us, how long will it take? Well, it's going to take 3 hours. Okay, so that's how we solve DTR problems. Okay, let's say I want to look at another DTR problem. Okay, if it takes a boat, okay, 3 hours to, if it takes a boat 3 hours to travel upshore, to travel upstream, upstream with the current, and 5 hours downstream against the current, how fast is the boat traveling? Okay. Okay. So when I look at this problem, I'm still going to have the D equals TR. Okay. Do I need more information here? I want to say I do. Okay, let's see. I've got, let me put in the distance. Let me see. I'll set this up and see what happens. Okay. Okay, so it's 3 hours to travel upstream with the current and 5 hours to travel downstream. Okay. I want to say I do need the distance. Okay, the distance the boat traveled was 800 miles. Okay, so we want to know how fast is the boat traveling. Okay, so we still got D equals TR. Okay. Okay, so now the way this is going to get set up here, we're going to set it up like this right here. We're going to say, well, okay, let's say we'll look at the first situation because we've got 2 separate events. Okay, we got the time, okay, but we don't know the speed. Now, in this case, we've got 2 speeds. We got the speed of the boat, and we got the speed of the water, the current. Okay, because the water is moving. Like if you took a leaf and put it into the water, it would move because there's a current. So there's some speed in the water. If you put a piece of paper in the water, it would just float downstream because the water is moving. Okay, so we've got two speeds. Okay, so now the way we're going to set this up, we're still going to set up the same way. I'm going to say, okay, I'm going to say D equals TR, and then I'm going to scroll, I'm going to text over here because I got two situations. D equals TR. Okay, so I got two of these. Okay, in both situations, the distance is going to be the same, 800 miles. Okay, now in the first one, I know what the time is. It's 3 hours. Okay, but what I don't know is I don't know I don't know how fast the boat is going. I don't know how fast the current's going. Okay, but I do know that the current is helping the boat out. Okay, because it's going with the current. So, and that's why it's faster. So I'm going to say x plus 1, x plus y. Okay, so it's helping out the boat. Okay, same way if you like put a cup in the water. If the cup doesn't do anything, the current is going to add to the speed of the cup. Okay, and then for the second one, I'm going to say 800 equals 5, and then that's going to be x plus y. Okay. Okay, so those are my two equations. Okay, well, obviously I got two equations here. So that's going to be a linear equation there. Okay. So the way I'm going to solve this problem is what I'm going to do is I'm going to say, okay, well, I'm going to rewrite it. Okay, I'm going to say 3x plus y equals 800. And then I'm going to put underneath it 5x plus y equals 800. Okay, so there we go. To solve this problem, what I'm going to do is, because this becomes a system of linear equations. So it's now a system of linear equations. Okay, now this concept is important because this is going to be on assignment 2. Okay, so this concept of systems of linear equations, you will see on assignment 2. Okay, and so you got to work with this concept there. Okay, so learning it now is going to be important. Okay, well, in order to solve this problem, what I'm going to have to do is I'm going to have to find the least common multiple between the 3 and the 5, because I'm going to have to find a way to cancel them out. Okay, I got to figure out how to cancel out one of them. So okay, so the least common multiple between these two things, let me put it here on the side, it's going to be 15. In other words, 3 times 5 is 15. Okay, and the least common multiple is important so that we can cancel them out. And the reason why we're able to multiply to do it because they're both prime numbers. Okay, so what I'm going to do in order to make that work is I'm going to multiply this one right here by negative 5. Let me see. I think both of these are going to cancel out. I'm not thinking my problem's going to help me out here. And then that was going to be negative 3. Okay. And then that means that and then I'll do the same thing over here. Negative 5. And then that's going to be, well, you know what? They both can't be negative. One has to be positive. and it's going to be 3 like that. Okay, so that'll work out. And the reason why one has to be negative and positive is so that they'll cancel each other out in the process. Okay, so um, okay, so that should work. Yeah, so that should work. Okay, you know what? Before I did that, what I should have did is I should have went ahead and just multiplied straight through. So let me do that first. I'm getting careless. Okay, so I'm going to go 3 times x is 3x plus 3 times y is 3y. And that's going to equal 800. And then I'm going to go 5 times x is 5x. I'm going to distribute 5 times y is 5y. And then that's going to equal 800. Okay. Now at this point, I can multiply both sides here by, I'll do -5 on the top one. And then I'll do +3 on the bottom one to cancel them out. Okay. Okay, so that's going to be -5. Okay, so that should do it. Okay, so now that's going to give me -15x plus, yeah, these are going to cancel each other out. I didn't set this up the right way. I can see it now, 15y. Basically what it's saying is that there's not going to be a solution for this one. -4,000. Yeah, that's going to, let's see. Yeah, they're going to cancel out. Mm. Let me see. Yeah, you know why they're going to cancel out? Because of this right here. I messed this one up. Okay, so let me start over. Okay, um, going upstream, and I'm gonna have to clean it up real good here. That's gonna be upstream, so I'm gonna have to add to take it upstream. Okay, going downstream, I'm gonna have to subtract, going against the current. So, you know what? Even my terminology is not right. This should be downstream. Downstream should be with the current, and upstream should be against the current. This was not a beautiful problem to begin with. Okay, so that's downstream. So downstream, obviously the current's going to go faster downstream, like water falling. You know, God, I really didn't do well on this at all. And upstream is going to be going against, so that's going to be subtracting. Okay, there we go. Let me change this to blue. Okay, so there we go. Okay, so this is going to be the equation upstream. Let me put upstream. I want to put against with it. Okay. And then I want to put with this one. I'm trying to clean this up. Okay. But this is the way it is in life. When you make a mistake, you gotta come back and figure out how to clean it up. And this way math is too. Okay. Okay. So let's start over. Okay. So the problem says if it takes a boat 3 hours to travel downstream with the current and 5 hours upstream, against the current. How fast is the boat traveling? The distance the boat traveled was 800 miles. Okay. Okay. So that's the problem. Okay. Now we still got to use D equals TR. That means the distance equals the time multiplied by the rate. We'll always have to use that formula. Okay. In this case right here, the distance is going to be, and let me bring this up some, is going to be D, which we know is given to us at 800. The time is going to be 3 because it's 3 hours. And then the rate is going to be composed of two things. The rate is going to be composed of the speed of the boat and the speed of the current. Okay, so when they're working together, you add them together. Okay, so when they're working together, you add them together. Now, in the second situation, they're not going to be working together. They're going to be working against each other. So we're going to say D equals, the time is going to be 5 hours. And then the rate, in this case, is going to be X minus Y. Okay. Anytime you have two different speeds, two different rates, you'll either add them together or subtract them. Okay, so the rate will be composed of two things. When you, like, if you got, like, you'll have another problem, and you'll see this one in ALEKS, where it'll talk about a plane, and it'll talk about a plane going with the wind and a plane going against the wind. Okay, when it's going with the wind, it's going to be X plus Y. When it's going against the wind, it's going to be X minus Y. Okay, so let's, with the wind equals X plus Y. Against the wind, it's going to be X minus Y. Okay, so we've got the wind, you will have the current. Okay, you can also use an elevator, you know, with the elevator. If a kid is walking with the elevator, it's going to equal X plus Y. Against the elevator will equal X minus Y. Okay, so in this case, we're talking about with current, it's going to be X plus Y. Against current, X minus Y. Okay. Um, the reason the rate has two variables is because we have two rates. We have the speed of the current and the speed. Let me make sure I'm spelling that right. Of the boat. Okay, so we got two speeds. Both speeds are unknown. Okay, so that's why we've got two. That's why we've got an X plus Y and an X minus Y, because the speed is unknown. The speed of the boat is unknown, and the speed of the current is unknown. Okay, so that's why we've got an X plus Y and an X minus Y. Okay, now in the X plus Y, the time is 3 hours. Okay, so time is 3. In the X minus Y, the time is 5 hours. And that stands to reason. Okay, the it should take less time if you've got faster speed, and it should take more time if you got slower speed. Okay, so now we're going to change this one down here, because that's not supposed to be X plus Y for 5. That's supposed to be X minus Y. Okay, and that's the same way here. Okay, so now that's going to change the problem around. And instead of putting that like that in parentheses like that, what I'm going to do is I'm going to do this right here. I'm going to put this whole thing like that. So after I multiplied, let me do this. Change that out. Change that out. And then I'm going to do this right here. Dot, 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 dot. And then I'm going to take this and cut it. Cut. And put it there. And then I'm going to do the same thing with the other one. And dot, 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 dot. And then I'm going to cut it too. Okay, so there we go. We'll take out that 15 there because we don't need that right now. Okay, so these are our new equations when we distribute it. Okay, so over here I'm going to say we use the distributed property. Okay, so we use the distributed property, and we simply took 3 multiplied it by x, took 3 multiplied it by y, and that's how we came up with 3x plus 3y. And everybody knows, let me take this part right here out for a second. What I'm going to do is copy it. Okay. That there's a 1 in front of the x and a 1 in front of the y, which is how we come up with the 3x, because we multiplied it 3 times the 1 and the 3 times the 1 in front of the y. Okay, so we distribute by multiplying whatever is on the outside of the parentheses by whatever is on the inside of the parentheses. Okay, so that's what we do. 3 times 1 is 3. 3 times 1 again is 3, and so we got 3x and 3y. So that's how we come about that. Okay, now the next step is going to be to use that LCM, the least common multiple. So I'm going to copy that, and then I'm going to bring that down here. And then I'm going to copy this one and bring it down. Now, the LCM in this case is going to be, I can get rid of the y by multiplying the top by 5. And so that'll give me 15 there. And let's see. Then I'm going to multiply this one right here by 3. Okay. They just have to be opposite of each other. So I'm going to try to get rid of the y by coming up with a negative 15y and a positive 15y. Okay, so 5 times 3 will give me 15y. And then 3 times negative 5 will give me negative 15y. And so that's going to cause them to cancel out when I add them together. So that's going to give me 15x plus 15y. And then that's going to equal 4,000. Then I'm put dots in here too. Dot, 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 dot. And then that's going to give me 15x minus 15y. And then that's going to equal 22,400. No more mistakes. Okay. Yes, it will. Yeah, it will. I'm recording it now. Okay. No, I don't. Everybody that registered for this go-to training, I got your email. Okay, so this is our problem. Okay, now we're going to use a method called the elimination method. Okay, and elimination means that we simply add these two things together. So what I'm going to do is I'm going to put a line underneath all this because it's all going to get added together. So 15x plus 15x, it's going to give me 30x. And then negative 15 and positive 15 is going to give me 0. So those two things are going to cancel out. So they're going to become nothing. And then I'll have 40,000 plus 2,400 is going to give me 6,400, like that. Okay. So now I got a brand new equation. The other one got canceled. You know, the y's got canceled out by doing this. So now I'm left with 30x equals 6,400. And from there, all I have to do is I'm going to divide both sides by 30 to get the x by itself. 6,400 divided by 30. So that's going to give me x equals, I pull that back up, 6,400 divided by 30. That didn't, 6,400 divided by 30. So that gave me, all right, so I'm going to put that over there to the side. So that's going to be 213 and 1/3. Okay, so that's what x equals. And x is the how fast the boat is traveling. So we're going to say that's 213 and 1/3 mile per hour. Or you could just say 213.333 .33. So we could say 200 when we divided it. It actually gave us this, but I converted it to a fraction, mph, or 213 and 1/3, because 0.3333, like, that is 1/3. Okay. Now, fortunate for me, that's what we were looking for, was the speed of the boat. Okay, y is the speed of the current. Okay, that's why it's being added to the boat and subtracted from the boat. If we wanted to figure out what y was, we would have to take that 213.33 and plug it back into one of these formulas here. We could plug it into this one or this one. So let me change these a different color so we can see. We could plug it. Well, let me just copy them. So we could take it. We could plug it into this one. It doesn't matter which one we plug it into. We could plug it into this one and solve for y. Okay, so we're going to say, well, 3x is going to be 213.333, and then y is still unknown, equals 800, like that. And at this point, we're just solving linear equations. So, you know, we're going to say 3 times that, which is going to be 639.99 plus 3y equals 800. Okay. And then from there, will subtract 639 from both sides. So we'll subtract 639.99 from both sides. And we're just trying to figure out what the current is. Even though we don't really have to know what the current is, we're just, you know, just trying to figure it out. And the reason why we don't have to know what the current is because the question didn't ask for it. So now we got, when we subtract this 639.99 from each other, that's going to leave us with just 3y. And then we're going to have 160 6.01. Okay. I'm going to double check that just to make sure. I just did that in my head. 800 minus 6. And my head's been a little foggy today, so yep. Okay, maybe I'm getting back on track. Okay, now the last step is we got to divide both sides by 3 to get rid of the 3. So we're going to divide this by 3. And then we're going to divide the other side by 3 too. 6.01 divided by 3. And that's going to give us, okay, so now we've got 53.34. So y equals 53.34. Okay, so now we know what that's 53 miles per hour. Okay, so now we know what the speed of we know what the speed of the boat is. Okay, so this one right here is the speed of the boat. Speed of boat. And we know the speed of the wind, speed of the current. Speed of boat, speed of current. Okay, so we got both. We got the speed of the boat and the speed of the current. The speed of the boat is 213 miles per hour, and the speed of the current is 53 miles per hour. And I suppose there's some places in the world where the river is actually moving at around 60 miles per hour, but that's definitely white, you know, rapid type water speed. Okay. Okay, but that's a made up problem, so okay, I made that problem up out of the top of my head. Okay, but that's how DTR problems work. Okay, this one it's got two equations in it because it's got two situations. One situation is where the boat's going downstream, and then another situation is where the boat is going upstream. Okay, every situation has its own equation. Okay, so just be mindful of that. If you got two different, you know, events, then each event is going to have its own equation. Okay. Does anybody have any questions about what I just did with DTR problems? Okay. Well, you want to start with just one, and then if there's more, we can just kind of pick them up as we go along. Okay, not a problem. Yeah, what you may want to do is take this go-to training and just replay it a few times. Okay, once you get past the mistake that I made early on, where I failed to subtract and I tried to add in both cases, even though I knew that, going with and going against were, two different events entirely. Once you get past that part of it, okay, and then just listen to it on, a few times, it'll click. It'll click. But at the end of the day, you've got to have a distance, you've got to have a time, and you've got to have a rate. Sometimes the distance is unknown. Sometimes the rate is unknown. In this case, the rate was unknown. Okay, the time was 5 hours and 3 hours, and then the distance was the same because you was traveling the same route. Only difference is one time you're traveling upstream, next time you're traveling downstream. Okay, but this entire problem works off of that concept of that formula. Okay, figuring out what D is, figuring out what time is, and figuring out what rate is. Sometimes we'll give that to you. Sometimes it'll be right there in the word problem. And then there's going to be stuff that's not going to be in the word problem. Like the rate was not in the word problem. So we had to use variables for the rate. And then we had to take in consideration of the current. We couldn't just use the rate by itself. Yeah, for LMS, it will be uploaded for LMS. I'll send it out to everybody in the go-to training and everybody that was registered for the go-to training. Okay, so I'll send it out that way. And then the second thing I'll do is I'll send it out to my class. I always do that. So my class gets all of my go-to trainings, plus everybody who registers for the go-to trainings get it. So you'll get you'll get an email because you were registered um, for this go-to training. And if you're in my class, then you'll see an announcement on the announcement board stating that here's the go-to training. Once I get it uploaded to YouTube. Okay, not a problem, John. Okay. So what other concepts would you guys like to work with today? Okay, so we did the DTR formula. Do you guys want to see another system of linear equations without the DTR involved in it? Just a raw math problem with the system of linear equations? Okay. Okay, so we'll go 2x plus 3y equals 8. And then we're going to say this one's going to be x plus 2y equals 4. Okay, so here we go. I'm going to make that 5. Okay. Okay, so here we go. Now the problem this is a system of linear equations problem too, but this is the pure math without the applications part of it. Okay, um, typically the way we teach math is we give you the pure math, and everybody knows that math is just a tool that we use to make decisions. Okay, just like if you went to wood shop, okay, you would have to learn how to use the tools before you could build anything. If you went to, say, culinary school, you would have to learn how to use the oven and the equipment before they let you cook anything. Well, this is what the math is. The math is just a tool. Okay, so what I'm getting ready to do now is show you the tool that we just use to solve that that DTR problem with the current or wind, in any given situation. So this is the tool we're going to use. It's called a system of linear equations. Now the reason why it's called a system of linear equations is because we've got two or more equations that have to have the same solution. So we could have 3 equations in here, okay, depending on how many situations or events that we have. Okay, so in this case, we've got 2x plus 3y equals 8 and we've got x plus 2y equals 5. Now, we've got to figure out which one of these variables we're going to get rid of, whether we want to get rid of x or whether we want to get rid of y. Okay, this method is called the elimination method. And then I'm going to show you another method in a second. This is called the elimination method for solving systems of linear equations. Okay, so this method is called the elimination method. So we're going to eliminate one of the variables and then solve the other one. Okay, now in this case, we're going to get rid of the x. It doesn't matter which one you get rid of. You can get rid of the y, you can get rid of the x. Okay, sometimes getting rid of a certain variable will create less work for you. Okay, but whether you have to do one step or two steps, you're still gonna come up with the same answer. Okay, so what I'm gonna do is I'm gonna get rid of the x's. Okay, so I'm gonna make the x's red because that's what I want to get rid of. Okay, now that first x is a 2x, and the second x, I'm gonna go ahead and put a 1 in front of it. It's really 1x. Okay, when you can't see the number, it's 1. Okay, so that's really 1x. Okay, now I'm going to look for the LCM between 1 and 2, and it's obviously 2 because 2 times 1 is 2. So what I'm going to do, the first one can stay like it is because it's already 2. And then the other one, I'm going to try to make it negative 2. Okay, and the reason why is because positive 2 and negative 2 will cancel out. Okay, so the way I'm going to do that is I'm going to multiply all of the second one by negative 2. I didn't really have to put all that there. Let me take this off. Quit. I'm going to cut this. Drop that down here. Okay, so what I'm going to do is bring it down here because I got work to do on the next one. So the next one is I'm going to multiply it by negative 2. There we go. 1x plus 2y equals 5. Okay. Okay, so here we go. Okay, so now when I multiply the 1x by negative 2, that's going to give me a negative 2x. Okay. Now, there's a rule for, finding equivalent equations. And an equivalent equation are equations that have the same values. Okay. They got the same solutions. Okay. So if I multiply everything by negative 2, I come up with an equivalent equation. So now I can do what I just got finished doing. 2x plus 3y then we're going to come here, and then I'm going to need that. So that's going to be negative 2x. You know what? I got to put some space between it. They're going to get confused. You're not going to be able to see my negative 2x. Yeah, there we go. Minus 4y. Everything multiplied by negative 2 is going to change the sign. Okay, so there we go right there. Okay, now these two things can now get added together. So we're going to underline it. And then that's going to give us positive 2x and negative 2x are going to cancel out. Then negative 4 and positive 3 will give me a negative y. Okay, so let's go back. Get rid of it. Okay, so we got negative y here. And then that's going to be a negative 10 and a positive 8. It's going to give me a negative 2. Okay, so now that's my, that's what's left to solve for. So I'm going to bring that down. Okay, now to finish this problem off, I just simply have to multiply both sides by negative 1. Okay, and then that'll make the negative y become a positive y. Okay, so we got negative 2 times negative, let me put the negative 1 in first. Negative 1 times negative 2. So y equals 2. Okay, so y equals 2. Okay, now to figure out what x is, I simply got to plug the value of y into one of the equations. Okay, so I'm going to plug it into the second one. So I'm going to take that second one, and then I'm going to plug in for y, I'm going to plug in 2. And I mean, you could pick either one. It doesn't matter. Okay, that's the nice thing about this process. It's a lot that doesn't matter. 4 equals 5. Okay, and then I got to subtract 4 from both sides. And then that's going to give me x equals 1. Okay, so now I know what y is. Y is 2. And x is 1. Okay, now I can go back and prove that. I'm going to take everything I got at the beginning. We'll copy that. Then I'm going to bring it down to the bottom. And I'm going to change the colors to all black. And then I'm going to copy it again and plug in the values for x and y just to prove my work. Okay, so I said x was 1. So I'm going to put in 1 for all my x's. And then at this point, it becomes just arithmetic. And I said y was 2. Okay, so at that point, then that gives me 2 times 1 is 2, plus 3 times 2 is 6, and that equals 8. And then the other one, 1 times 1 is 1, 2 times 2 is 4. Make sure you just follow the order of operations on these and you'll be fine. Okay, so it works. So my final solution is when x is 1, so you can put your solution like this, where you put x first and then y second like that. So that means that when x is 1 and y is 2, okay, we get a solution that works for both equations. Okay, all right, does anyone have a question about what I just did? Okay, that method is called the elimination method. Okay, you use a least common multiple, and that concept of least common multiple um, is a concept that we see in fractions. Okay, now it doesn't have to be the smallest. We can just multiply them together and come up with any common multiple, as long as we can get them to cancel out. All right, what I want to do is I'm going to give you guys one. So we're going to say 2y minus x equals 7. And then we're going to have 3y plus, we'll say 5x equals 18. We'll say 10. 13. There we go. Okay, so you guys see if you can solve this one. See if you guys can figure out what x and y is, and see if you can find the least common multiple. Okay, so you guys let me know when you got an answer. Okay, how's everybody else looking? Does anybody think they can solve it, or does everybody think they need to see it? Okay, let's get some input. What do you guys think? You guys think you can solve it, or do you need, let's see me work it out. Okay. Okay, what about everybody else? Okay, let's see. We still, well, just Cassidy. Okay, Cassidy, what about you? Do you need to see it? Okay. All right. Okay, so this is what I'm going to do. I'm going to focus in on the x's, getting rid of them. Okay, now, if I've got negative 1x and I got positive 5x, then the least common multiple between 1 and 5 is 5, because 5 times 1 is 5. So all I need to do is multiply the top one by 5. And then that'll give me, and I'm going to make this black so you can see the changes I've done here. Okay, so if I multiply that by 5, that'll give me a negative 5x for the x value. Okay, which is what I want to do because I need to cancel them out. Okay, so that's going to give me this right here. So I'm going to end up with 10y, 5 times 2 is 10y, minus 5x, 5 times negative 1 is negative 5x, and then 7 times 5 is 35. And I got to change that to black so I don't run into problems with that. Now I still got 3y plus 5x equals 13. Equals 13. Okay, so now I'm ready to add. And I'm going to eliminate through addition. Okay, so I can add the 10 and 3 together and come up with 13. And I can add the 35 and the 13 together and come up with 48. Okay, so now all I got to do is just solve for y. Okay, so because I eliminated x, so now I got to solve for y. So I'm going to divide both sides by 13. 13y divided by 13 equals 48 divided by 13. And that's going to leave me with y equals 48 over 13. And I'm going to leave it like that. I don't really have to convert it to a decimal. Okay, so that's my answer. Y equals 48 over 13. Now, I still need to figure out what x is. Okay, so I'm going to take x and put, well, it doesn't matter which one I use, but I'm going to use the first one because x is already kind of simple as a negative 1. So all I really need to do is just figure out, just plug in y and then get everything away from x, and then I'll be finished. So I'm going to go 2. Let me change that to black because I don't, let me see all that red. 2, and then that's going to be 48 over 13. minus 1x is really, well, I'm going to leave it at just x. It doesn't matter because 1, negative 1 and just negative x like that mean the same thing, equals 7. Okay. And so now I just got to do the math. Okay. Well, 2 can be 2 over 1. Okay. So that's really going to be 98 over 13. And that's just, basic rules for multiplying fractions. 2 times 48 is, it's not 98, it's 96. That was fun while it lasted. Minus x equals 7. Okay, so from here I've got to get rid of the 96 over 13. And I'm just taking a second to go back and make sure I got it right, because once I did that, then it kind of made me nervous. So now I'm wanting to double check my work. Okay, so now we got 96 over 13 minus 96 over 13 minus x. And the reason why is because that's a positive 96 over 13. So I'm trying to get rid of it. So now I've got 7 here minus 96 over 13. Okay, so the the 96 over 13 minus the 96 over 13 are going to cancel out, and I'm going to be left with negative x. And then you can't subtract 96 over 13 from 7. I've got to convert that 7 into a fraction. And so what I'm going to do is, I know 13's got to be my denominator. So what I'm going to do is I'm going to take 7 and I'm going to multiply it by 13, and then I'm going to divide it by 13. So I'll still have the same value. So I'm going to go 7 times 13 will give me 91. So that's going to give me 91, and then that's going to be 91 over 13. And then, of course, if you divide 91 over 13, it'll come back to 7. So if you multiply 7 by 13 and divide it by 13, the multiplication of 13 and the division of 13 are canceling out, and that's leaving you with 7. But what it's doing is it's allowing me to have the same denominators. Okay, and so that's going to give me 96 over 13. And then that's going to give me negative x. And then, of course, 91 minus 96 is going to give me negative 5 over 13. And then my final step is to multiply both sides by negative 1. So our final answer, and this was like swimming in fractions when we finish. So the final answer is going to be, x is going to be 5 over 13, and y is going to be 48 over 13. Okay, so that's your final answer. Okay, what I want to do is I want to give you guys one that is a little simpler, where you don't have to, look for the LCM, because I want to see if you guys understand the basis behind the elimination process. So I'm going to give you guys one a little bit simpler, where you can do the work and it's not going to spring off into fractions like this, and you don't have to have that understanding of fractions with the LCDs or LCMs in order to solve it. Okay, so I'm going to give you guys one more. Okay, so we're going to say, let's see, 2x minus y equals 10. And we're going to have 3x plus y equals 15. Make it 20. Okay, so you guys see if you guys, I want you guys to solve this one. Okay, so I've taken the fractions out of it. And when I say taking fractions out of it, that means your solution is not going to be a fraction. It's going to be whole numbers. And you're not going to have to find the LCD or LCM. All you have to do is just demonstrate to me that you understand how to use the elimination method to find the solution for a system of linear equations. Um, I don't think one is negative, John. No, in fact, I'm pretty positive one of them is not going to be negative. Okay, did you guys verify that answer? Your solution is x is 6 and y is 2. Okay, let's verify it. Okay, thank you, Cassidy. Okay, thank you, Priscilla. Okay, how about everybody else? How are you guys doing? Okay, great. Okay, does everybody else need extra time, or are you ready to see the problem worked out? Okay, do we need extra time? Or are you guys ready to see the problem worked out? Okay. All right, so Priscilla and Cassidy, you guys got this one right. So what variable did you guys get rid of first? Okay, and why did you guys choose Y? Why Y? Okay, excellent, because it cancels out immediately. Okay, it cancels out immediately. So when we look at this problem, those Y's are going to cancel out immediately. Okay, see that? Now we can put if you need to, just go ahead. If there's not a number there, you can put a number in front of Y, which is going to be 1. So, -1 and +1 cancel each other out. So now you're left with, they're going to cancel out when you add them together. So then you just say 2x plus 3x will give you 5x. Excuse me. And then 10 plus 20 is going to give you 30. Now from there, 5 times some number is 30. We can pretty much figure this out without having to divide both sides by 5. We can look at it and see that 5 times 6 is 30. So we know x is 6, but I'm going to go ahead and work through the math, just in case we need to practice. Divide both sides by 5. X equals 6. Yeah. Okay, so x equals 6. Okay, now we're going to take one of these problems. I'll take the first one. It really does, in this case, it really doesn't matter. Okay, you won't save yourself any extra time by picking one over the other. So we're going to put 2, we're going to put 5 and 6 in here. Minus y equals 10. And that's going to give us 12. 6 times 2 is 12. Minus y equals 10. Now, you can go on with this problem and go step by step, but 12 minus 2 is 10. So we know y is 2 because 12 minus 2 is 10. Okay, but I'm going to go ahead and finish up the math anyway, just for the practice. Sometimes if you're having problems with a concept, even though you know the, the outcome, it's best to practice the steps anyway. So like, playing, basketball or something. Okay, you may know how to shoot free throws, but you probably need to practice them. Or singing a song, you may know the song, but practicing the song will help you to remember it or help you get better at it, help you sing it better. Okay, and so then the last step is going to be to multiply both sides by -1. Okay, so we'll say -1 by both sides, and that's because we're not looking for a negative y, we're looking for a positive y. Okay, and then on the other side we're going to go -1. Okay, so we see, and I'm going to put those in red. We can see that Cassidy and Priscilla were right, and that's x is 6 and y is 2. Okay, okay, so that's the elimination method of addition. Okay, now, that method works on those, when the going against and with the wind and going against and with the current. Okay, that system of linear equations, and you're using the elimination method. Okay, the other elimination method we're going to see is the other, not elimination. The other method we're going to see to solve systems of linear equations is going to be the substitution method. Okay, I'm going to show you one of those, and then if someone else wants to see another concept, with our last 30 minutes, we're going to take time for that. So let's see, I'm going to take all this out. And then what I'm going to do is put in y equals 2x plus 1. And then I'm going to have 2x. Now, I'm about to stay away from 2x. I'm going to have x plus 3y equals 5. Okay, so now I'm going to take this value right here for y. Okay, now it's called the substitution method, obviously because you're substituting something in. Okay, remember earlier when we talked about the substitution property, we said if two things equal each other, you can substitute one for the other one. Well, if y equals 2x plus 1, guess what you can do? You can substitute in 2x plus 1 for y. Okay, so that's what the substitution property says, is that we can replace one thing with the other one if they're equal to each other. Okay, and so that's what we're going to do here. That's why it's called the substitution method, because we're going to use the substitution property. Okay, so we've got x plus 3, and then we're going to substitute in 2x plus 1. Okay, and I'm going to put that in red, and then we're going to say equals 5. Okay, because if they equal each other, then we can substitute in one for the other. Okay, so that's what we did, or replace one with the other. Okay, y equals 2x plus 1, so we can take out the y in the second equation and put in a 2x plus 1. Now we still got to do the math. Okay, at this point, this is a linear equation with one variable that we're solving for. So we're going to have x, and then we're going to distribute. 3 times 2 is 6x, and 3 times 1 is 3, equals 5. And from there, we'll add the two x's together and come up with 7x plus 3 equals 5. And then from there, we'll subtract 3 from both sides. Plus 3 minus 3. 5 minus 3. And that's going to give us, and this one's going to turn out to be a fraction, equals 2. And then the last thing we'll do is we'll divide 7 from both sides. So we got 7x divided by 7 equals 2 divided by 7. And x equals 2/7. So that's one. Then the other one is going to be, we've got to solve for y. So I'm going to use the original one where it says y equals. The math would just be easier if I use that one. So all I have to do is just simply plug in for x equals 2/7 plus 1. And 2 times 2/7 is going to be 4/7 plus 1. Now we know the 1 is going to be converted to 7/7 because you can't add the fractions when the denominators are not alike. So it's going to be equals 4/7. Now where did that come from? I just took that 7, the denominator, and took the 1/1 and just multiplied the top by 7. I just said 7 times 1, and then 7 divided by that answer. So 7 times 1 is 7, and then 7 divided by it is 7. So 7 divided by 7 brings you right back to 1. And that's a fraction concept. And then 4 plus 7 is 11/7. So the final answer is going to be, x is going to be 2/7. And y is going to be 11/7. Okay, so that's our answer. X is 2/7. And we can see that right here anyway. Let's see. Make that blue. And right here for y. Okay. Okay, so that method is called the substitution method. Okay, so we got two methods. We've got elimination method and a substitution method. Okay, now When do we use the substitution method and when do we use the elimination method? Okay, I'm going to clear this because I want to show you two different problems. And you'll see when they look different, when it's best to use what method. Okay, so the substitution method is it when you have a problem like this right here, x equals 3y plus 2, 3x minus y equals 1. Okay, so notice this right here. Now I'm going to change the color of this one. Well, let me leave this one. I want the red one to be so you can see it. Anytime you got a variable isolated, you're going to use the substitution method like this. Okay, then I'm going to go over and then we're going to use the elimination method. Two x plus 3y equals 7. X minus x plus 2y equals 4, like that. Okay, and let's do some color changing here. Black, that's black. Okay, that's gonna be black. And let's see, we got, this is gonna be red. When you have both variables on the same side, then you can use the, let me make that black too so we can see this. Okay, when you have both variables on the same side, then you can use the elimination method. Okay, so the substitution method is when we have a variable isolated all by itself, like the x is isolated. So we'll use the substitution method there. Okay, and in the substitution method, we'll simply take out the x and put in, I'm going to change it to blue. And then right here where you see the x at the bottom here. Okay, so that's where the substitution will go. We'll take out the x and put in the 3y plus 2. Okay, in the elimination method, when the both variables on the same side, we got to find the opposite of 1. Okay, for that elimination method, which variable would it be the easiest to eliminate? Which one do you guys think would be easiest to eliminate, the x or the y? Okay, why do you say the x, Priscilla? Okay, that's for the first one. But what about for the second one in the elimination method? Okay, so for the first one, we will eliminate the x by substituting. But what about the second one? Oh yeah, I see what you're saying. You're saying because that's 1x. Okay, yeah, I see what you're saying. You're saying because this is a 1x here, it would be easier to just find something to multiply it by. Okay. Does anybody know what we're going to multiply it by? What will we multiply it by? Okay, class, help her out. Yeah, it's going to be a 2, but it's going to be a negative 2. Okay, so this entire thing here is going to be multiplied by a negative 2. So we're gonna take a negative 2 to it. Okay, why do you guys think it's a negative 2 instead of a positive 2? Why -2 instead of a +2? Right. So that because what will happen is we'll end up with a +2x and a -2x, and so they'll cancel out like Cassidy said. Okay, so that's what will happen. The +2x and the -2x. See, because -2 times 1 is going to give us -2. So we're going at the bottom we're going to have -2x. Okay. And of course, -2 times 2 will give us -4. So this entire one, when we get finished with it, is going to end up being -2x minus 4y equals -8. Okay, so that's what it's going to be. And of course, the -2x here, okay, and and the +2x here will cancel out when you add those two things together. Okay, so that's why it's got to be a -2 and not a +2, because a +2 will give you a 2x, and then 2x and 2x will double to 4x. Okay, that's enough of the system of linear equations. Okay, you'll see the systems of linear equations as a tool that will ask you to learn how to, you know, work the tool. Then you'll also see that tool in an application when you're dealing with DTR problems. I think you're going to see it with, there's going to be a water pump problem that's going to require you to use a system of linear equations. And then there's definitely going to be an airplane problem that's going to require you to use systems of linear equations. And then there's probably going to be a boat problem. All those things got one thing in common. Okay, you got two speeds. Well, okay. So that's it. You'll have two speeds. One's current, one's wind. Okay, and then there's the boat. Okay, and then there's the airplane. And then I think there will be one elevator problem. Kid going, walking, with the elevator, versus walking against the elevator. So you'll probably see that too. Anytime you got two different speeds, two different things moving, then you're gonna see these linear equations, systems of linear equations. All right, that is enough of those systems of linear equations and DTR problems. Okay. Um, is there another concept you guys want to talk about? Or does someone have, like maybe specific questions? Okay, or something you've seen in ALEKS that you need some clarification on? Okay, well, if your brain is full, okay, I'm gonna be here until 5 o'clock. So I mean, you guys are free to check out at this point. You'll get a recording of everything. Okay. So I mean, you're not gonna miss anything if you. Okay. Yeah. That assignment is what we cover. The assignment two. Okay. So the assignment two, Duran, if that's what you're talking about, yeah, that we cover that today with the linear equation stuff. Yeah, that sounds like a good idea. Okay. I'm gonna pull up that assignment too. Okay, so I'll pull it up and look at it. Assignment two. Yeah, let's look at it. All right, so we're pulling it up now. Okay. Yeah, yeah, this first problem right here, okay, that's going to be a system of linear equations. This one right here is a proportion problem. Okay. This one right here, you can use um, substitution on it, or you can use system on it, because you got a profit of 8,500. Okay, total expenses of that, where T is the number of months. How long will it take to break even? So, this one is going to equal that one, so to speak. Um, Here's another one here. Okay, that's a system right there. Okay, I think this was a proportion problem there. Okay, let's see. Rationale, no, that's nothing. The bus travel first. Okay, this is a regular DTR problem here. It's not even, so that's going to be a regular one. What, Duran, this one's archived. Okay, you'll actually get, if you register for like my go-to trainings, even if you don't come to the go-to training, everybody that registered still gets a copy of the archive version. Okay, so you've got like two, I think two or three. Okay, so number one is going to be a system. Number seven is going to be a system, because you can see the two equations right there. I think that's it. Number seven, number one, and this one right here. Yeah, you can work this one as a system, or you can work it as an equation. Okay, so yeah, this one right here can be more working like an equation, because if it's like a break even, that's where the revenue and expenses equal each other. So that's just going to be a regular equation, really. So the only two that you really have to work as a system is this one right here, and where's the other one at? I know I just seen it. And this one right here. So you only got two of them. But most of these problems are like proportions and ratio problems. Okay, so most of them going to be like proportion and ratios. And anytime you see words like rate, then that's what that's going to be. And then this like this is a formula problem right here, where you just got to plug in the numbers to the formula to solve it. Yeah, I think this one's doing the 13th. And then this one right here is a formula too. You take and put in these values right here into this formula down here. Okay, then everything else is going to be like proportions and ratios and rates. Okay, I think, don't quote me for say exactly on it. Okay, no, it's due on the 18th. Yeah, the due date is the 18th, September 18th. Yeah, so you guys got time on it. Yeah, says it right. Yeah, September 18th. So we got time. I'll pull that dashboard up again. Okay, so right now the only thing that's coming up is the modules, okay, and the homework quizzes, which are due on Sunday. Okay. Okay, so it's 4:42. Okay, at this point, I'm just gonna field questions. Okay, I think we've covered enough material with me lecturing. So we're gonna take the next 18 minutes and just field questions. Okay, if you don't have any questions, feel free to leave. All right, you're welcome, Cassidy. You enjoy the rest of your day as well. I'm gonna watch the football game tonight. Go Steelers or no Steelers, John? Oh, you're a Bengals fan. Okay, yeah, so I know what you mean right now. No. When you said you was a Bengals fan, that explained everything. You too, Priscilla. Well, Deborah, it's just me and you. What do you think? Okay, at this point, Deborah, I'm going to stop the recording, but I'll be here for another 15 minutes. If you have any questions, let me know. Okay, it's just you and I.